Alright, well, one thing before we get on to lists is how I forgot to mention in the last video about arithmetic how you do exponents. Like in regular math you do like 5 squared. Well, in this one you do expt, and then like 5, which is your base number, and then however much you want to square it. So 2. Alright, then we get 25 like expected. Now alright, let's move on to lists. Okay, I'll clear this by hitting the run button. Okay, so a list is just basically, well, it's sort of a lot like the rest of the scheme language. It's just parentheses. Well, you can create it with the list function here, and then you can list some objects like numbers, and there you get like just a list of numbers. Okay, now I've not told you about symbols yet, but symbols are just like a label. So you put a quote like this, and then you put something like B, or like a name like Jimmy. Oops. Alright, now you can also put those inside your list. So you can list Jimmy 4340. There you go, you get a list of that. Now you can also use the quote symbol just to make a list real fast, and any words in there are going to be taken as symbols. It's like Jimmy 340. Now that's the same thing as when we use the list keyword, but the difference between this one and this one is that in this list function it will evaluate these before it puts it inside of a list. So let's say we've got pi defined pi 3.14. Now if we do this, a list containing pi, see, it's just a list of the two symbols, pi and pi. But if we do list pi, then we get that. Now what if we do this, list pi, what's that gonna do? Well, the first thing here, because it has a quote on it, it's a symbol, so it's just going to say pi. But the second one is defined as a variable here, so it's going to say 3.14. And there we go, we got it. Alright, now at the base of every list is an empty list. Alright, so you start out with an empty list and you put things in it, and how you do that is with the constructor function. This is supposing if you're not using list. List actually just uses the constructor function here. So we'll do cons, that stands for constructor, I believe. Cons, and we'll put 5 inside the empty list, and then we get a list with 5 in it. So what if we wanted a list with 3 and 5 in it? What if we wanted like this, 3, 5? How would we construct that? Let's try like cons 3, 5, and then the empty list. Do you suppose that'll work? No, it doesn't work, because cons only takes 2 arguments. One is a list or something, the base, and then you've got the thing you want to stick inside the base. Alright, so let's try a different thing. Let's try cons 3, 5 into the empty list. But then we get a list of 3 and 5. Alright, let's do this. Cons 3 into 5. A list with 5 in it already. And that gives us what we want. Alright, but do you remember how we got this list here? Suppose we don't want to use the quote at all. Then we can just put in how we got that list in the first place, which is up here. cons 5 into the empty list. Alright, so let's do this. Cons 3 into cons 5 into the empty list. And there we get it again. Alright, so that's the way to do it. Now how do you access things out of the list? Let's define a list. Define ls A, B, C. Alright, let's say how are we going to get anything out of this list here? Well, you can think of well, I'm not quite sure why it's named this, but there's a function or a procedure called car, and that will just take out the first element of the list. So car of ls is A, of course. Alright, now then there's another one called cudder. Now I don't know how to name that either. Cudder ls. And this, I'll just show you what it does. It basically just takes the remainder of the list here. So what if you wanted to get B out of the list? You know that car can access the first element of it, but if we do that on this list here, then we just get A. But what but if we did it on the cudder of ls, then we get B. So we'll do car on the cudder of ls, and there we get B. That's nice. How do we get C then? Go ahead, think about it. You might want to pause the video and think about it and try to actually do it. Try to get B out of C out of this list. And now I'll show you how to do it. Car of the cudder, cudder of ls. There we go, it's C. Okay, now if you don't want to write this out every time, Scheme has some shortcuts. You can do car like that, but instead of finishing it off, you do D, which is cudder, and then another D, which is the other cudder, and then you finish off with the R to show that you're done of ls, and that'll give us the same result. And you can do that for up to 4 of these car cudder combinations, and you can do it in any sort of combination. Alright then, now lists can also contain other lists. So let's say like this. Let's do a list of pairs like A is 5, B 6, C 23. Alright, so we got a list of that. Now let's define that as ages. Let's pretend that these are the names of people with their ages. Okay, so let's say we want to get the age of A here. Then we can access that. How do we just get this list? A5. That's just with car of ages. Okay, A5. Now how do we get the age out of that list? The car is A, and then the car of the cudder is 5. So we do car of the cudder of the car of ages. And that gives us 5. Now remember that trick I taught you, this thing here. So how would we use that on this? We do start up with the C, and then A for the car, D, and then an A again, and then an R. Ages. And there, it's the same thing. Now how about let's try to get 23 out of this, and that's tricky. So the car of the cudder, this would be the cudder, and then the cudder of the cudder is that. So let's try that. Car of the cudder of ages, and we get that. Now let's do the car. We'll do the car of the cutter of that, and that will get us 23. Car of the cutter, and then we just copy and paste this to there. Now we've got 23. Alright, so I've showed you how to construct those lists and how to access things out of them. And next I'll show you how it actually, the diagrams actually, the actual construction of the lists.